All right, let's dive in. Get ready, because today we're tackling quantum computing.
Oh, quantum computing, huh?
Yeah. Now, I know what you're thinking.
Yeah.
Not another explainer on quantum computing.
Right, everyone's talking about it.
Exactly. But trust me, this one's going to be a bit different. We're going beyond just the buzzwords. We're going to get down to the nitty-gritty of why this tech is so revolutionary.
So where are we getting our info from?
We'll be diving deep into Microsoft Azure's own explainer on quantum computing.
Nice, Microsoft.
Yeah. And they've actually put together some seriously fascinating insights. I was reading through it earlier, and I was like, whoa, this is really cool stuff.
I'm intrigued already.
So today, our mission is to demystify the science behind quantum computing,
Sounds good.
explore all of its mind-bending potential, and maybe even uncover some surprising facts along the way.
Okay, I'm ready to take the quantum leap.
Perfect. Now, the source does a great job of defining those key terms right off the bat.
That's always helpful.
But let's be honest, words like quantum and qubit, they can still sound kind of intimidating.
Yeah, they do. They kind of have a certain mystique about them.
Right.
But when you really boil it down, they're actually fairly straightforward concepts.
Okay, good.
So let's start with quantum. Just think of it as the smallest possible measurement of a physical property.
Okay.
So imagine the tiniest drop of water you can possibly conceive of.
Okay.
That's the idea.
Got it.
Is like the building block of reality.
Okay, so we're talking about, like, the foundation of everything.
Exactly.
But how does that actually translate into computing?
So that's where the qubit comes in. Think of it like the quantum equivalent of a bit,
Right.
which is the fundamental unit of information in, our current computers.
Right, standard computers. Got it.
Yeah, exactly. But here's where it gets really interesting. A bit can be either a 0 or a 1, right?
Right.
But a qubit, thanks to this crazy world of quantum mechanics, can be both 0 and 1 simultaneously.
Oh, wait a minute. So it can be both at the same time.
At the same time,
That kind of challenges everything we know about, like, traditional computing.
it really does.
So how does that even work in the quantum realm? Being in two states at once.
Well, it all comes down to this concept called superposition. And remember how we were talking about quantum being the smallest unit of a property?
Yeah.
In superposition, a quantum particle can actually exist in all of its possible states at once.
At the same time.
At the same time. Crazy, right?
That's wild.
It's only when we actually try to measure it that it collapses into a single state.
Oh, so it's almost like the act of us trying to observe it forces it to choose a side, in a way.
You got it.
Okay.
And it's this very ability to exist in multiple states at once that gives quantum computers their incredible power.
I see.
Think about it like this. A traditional computer, right?
Yeah.
It processes information bit by bit, step by step.
Right.
But a quantum computer,
Yeah.
with its qubits all in superposition,
Yeah.
it can actually explore a vast number of possibilities at the same time, concurrently, all at once.
Oh.
Like if you can imagine reading every single page of a book simultaneously.
Oh, wow. Okay, now that is powerful.
That's the kind of power we're talking about here.
So we're not just talking about, like, faster calculations or anything like that. We're talking about a whole different way of approaching problems.
A totally different way.
Exactly. Wow. Now, the source also mentions this other mind-bending concept.
Oh, here we go.
I know, right? Called entanglement.
Yeah, entanglement.
What's that all about?
Okay, so entanglement. This is a phenomenon where two or more of these quantum particles, they become linked.
Linked?
Yeah, they become linked even if they're physically separated.
Okay.
It's kind of like, imagine two coins flipping in perfect sync no matter how far apart they are.
Okay.
And what's wild is that an action performed on one particle, it can instantly affect the other one.
Instantly?
Yeah, like faster than the speed of light.
No way.
It's like they're communicating somehow.
Oh.
Einstein actually called it spooky action at a distance.
Spooky is right. That sounds like something straight out of, like, a science fiction movie.
It really does.
But what are the real-world implications of this?
I mean, are there any?
Yeah. Can we actually harness this, like, spookiness for practical applications?
You better believe it. One area where entanglement could be totally transformative is in secure communication.
Really?
Imagine if we could transmit information encoded in the entanglement of these linked particles.
Right.
That would basically create an unbreakable code.
Oh, wow.
Yeah, because any attempt to intercept it, like eavesdrop on the communication, it would disrupt the entanglement.
And then you'd know, right?
Exactly. Both parties would immediately know that there's a breach.
Oh, that's brilliant.
You
That's
know?
like, yeah, straight out of a spy movie.
So we're talking about communication that's basically impossible to hack.
That's what we're talking about.
That's huge, especially when you think about cybersecurity, intelligence agencies, personal privacy, all that.
All of that.
Yeah. That's amazing.
And that's just one example.
Of how entanglement could totally change how we communicate and share information in the future.
Okay, all right. So before we jump into all the applications of quantum computing,
Okay.
there's one more term that the source mentions,
Okay.
and I want to unpack it a little bit.
All right.
Quantum interference.
Okay, yeah.
What is that?
So quantum interference, this is how a qubit's superposition can actually influence the probability of it collapsing into a specific state.
Oh, okay.
So it's kind of like all these qubits are like chatting with each other, creating these ripples of influence.
They're all influencing each other.
They're all tied together.
So it's like you're trying to create this perfectly calm pond for these qubits to do their delicate quantum dance
You got it.
without any disruptive ripples.
Right. You don't want any AS in there.
And that's why companies like Microsoft,
Yeah,
they're developing these innovative qubit designs,
that's right.
like topological qubits, which are inherently more stable and less susceptible to interference.
Way more stable.
It's like they're building tiny fortresses for these qubits to live in and be protected from the chaos of the outside world.
Exactly. Keep them safe and sound.
Now that we've covered kind of the basics, let's dive into the actual architecture of a quantum computer and see how all of these pieces fit together.
Okay, let's crack it open.
What's under the hood of these quantum machines?
Yeah, what's going on in there? Well, the source breaks it down to three main parts.
Yep.
First, you've got the qubit housing.
Uh-huh.
This is like that super specialized environment where the qubits are kept. You know how sensitive they are.
Right.
And then there's a whole system for transferring signals to the qubits.
Okay.
This lets us actually control and manipulate them, tell them what to do.
Yeah.
And then finally, there's a good old-fashioned classical computer.
Okay.
This is kind of like the brains of the operation.
Right.
It's running the program and sending instructions over to the quantum part of the system.
So it's like this delicate dance between the classical and the quantum world,
It really is.
each playing a crucial role in this, like, intricate computational ballet.
It's a beautiful thing.
I love that analogy.
Ah.
So tell me more about this qubit housing.
Yeah.
It sounds like something straight out of the science fiction lab.
Oh, it definitely is. For certain types of qubits, they have to be kept incredibly cold.
How cold are we talking?
We're talking just a hair above absolute zero.
Wow.
Colder than interstellar space.
That's mind-blowing.
It's pretty amazing.
And why is this extreme cold so important for these quantum systems?
Well, it all comes down to those delicate quantum states. At these super low temperatures, the qubits are way less likely to be, like, messed up,
Okay.
disrupted by their environment. It's all about creating that perfectly still pond, so to speak,
Yeah.
allowing those qubits to do their thing, perform their quantum calculations without any disturbances.
So we've got these super cooled qubits nestled in their little protective housing,
Yeah.
receiving instructions from the classical computer.
Right.
But the source makes this point that quantum computers aren't just like faster versions of our current computers.
Right.
It's not just about speed.
Exactly. It's a common misconception. People think, oh, quantum computers, everything's going to be lightning fast.
Right.
But it's not really about that.
Okay.
Quantum computers are the specialized tools.
Okay.
They excel at specific types of problems
I see.
where their unique capabilities, like, superposition and entanglement,
Yeah.
they really give them a huge advantage.
All right.
They're not about brute force computation.
Right.
It's about using those kind of counterintuitive laws of quantum mechanics
Yeah.
to tackle problems that would take classical computers, I don't know, centuries or even millennia to solve.
So we're not talking about simply upgrading our current technology. We're talking about an entirely new way of thinking about computation.
Exactly. A paradigm shift.
Now, the source highlights several areas where quantum computing could have a seriously huge impact.
Really big impact, yeah.
Yeah. Let's dive into a few of those.
Let's do it.
Starting with quantum simulation.
Okay.
What is that and why is it so exciting?
Quantum simulation is basically using these quantum systems to understand and model other quantum systems.
Okay.
So think about things like, I don't know, photosynthesis,
Okay.
or the way molecules behave, or how new materials are developed.
Yeah.
These are incredibly complex processes, and they're really hard to simulate on regular computers
Right.
because there's just so much quantum stuff going on at the same time.
So it's almost like using one quantum system to unlock the secrets of another quantum system.
Yeah.
Like fight fire with fire.
Yeah.
But What makes this approach so powerful?
The key here is that quantum computers, they operate on the same fundamental principles as the systems they're simulating.
Oh, I see.
So they can create much more accurate models.
Okay.
And those models can reveal insights that would be impossible to get with a classical computer.
So we could be talking about designing brand new materials.
Exactly.
With properties that we can't even imagine today.
Right.
Or developing life-saving drugs with pinpoint accuracy.
All of that, yeah.
That's the kind of progress that gets me really excited.
It's amazing.
Speaking of potential, the source also talks about cryptography.
Yeah,
Now, this one seems like it could be a double-edged sword.
it is.
What's the story there?
So cryptography is a great example of how quantum computing could both disrupt and revolutionize our world.
Okay.
You know how a lot of our digital security relies on encryption algorithms?
Yeah.
The ones that are really tough for classical computers to break?
Right.
Well, quantum computers, with their ability to explore tons of possibilities at once, they could potentially crack those codes.
Oh, no. That's not good.
I know, right? It can make our current security measures totally obsolete.
So are we all headed for like a digital Wild West?
Where our data is constantly at risk.
Yeah.
Well, not necessarily.
Okay, good.
The same principles that could be used to break existing encryption can also be used to create brand new unbreakable ones
Really?
based on those quantum mechanics principles. It's kind of a race against time, though.
I see.
You know, we got to develop and implement these quantum-resistant security protocols before, the bad guys get their hands on powerful quantum computers.
So it's like a quantum arms race,
Yeah.
with both sides vying for control of this new technology.
Exactly. It's high stakes.
But cryptography isn't the only area where quantum computing could have a big impact.
No.
The source also mentions optimization.
Oh, yeah.
What's that all about?
So optimization is about finding the best possible solution to a problem,
Okay.
given certain limitations or constraints.
Okay.
And this has applications in a ton of different fields, from logistics and transportation to finance, manufacturing, even city planning.
So are we talking about like optimizing traffic flow in our cities?
Yes.
Finding the best routes for package deliveries, or even maximizing the performance of complex financial models?
All of that. Quantum computers could totally revolutionize how we approach optimization problems.
That sounds amazing.
It's like, imagine a world where traffic lights are adapting in real time.
Yeah.
To minimize congestion, delivery networks operating with super efficiency, financial models predicting markets with amazing accuracy.
Okay, that sounds like a world I want to live in.
It's a good world.
Less traffic, faster deliveries, more predictable markets. Sign me up.
Yeah, I'm with you.
Now, the source also touches on an area that's been getting a lot of buzz lately:
What's that?
quantum machine learning.
Oh, yeah, that's a hot topic.
What's the connection there?
Well, machine learning's already doing some pretty amazing things.
Right.
But training those complex machine learning models takes a ton of computational power.
Right.
And that's where quantum computing comes in. It could speed up the training process like crazy, leading to some major breakthroughs.
In what areas?
Oh, all sorts of things. Drug discovery, material science, personalized medicine, even artificial intelligence.
So we're talking about like supercharging our AI capabilities,
Exactly.
potentially creating a whole new generation of intelligent systems.
It's like AI on steroids.
That's a bit scary, but also really cool.
It is, isn't it?
Are there any other applications highlighted in the source that we should touch on?
Yeah, there's one more that's worth mentioning. Search.
Search.
It might sound kind of simple,
Yeah?
but the implications are huge. Imagine being able to search through massive amounts of data almost instantly,
Okay.
finding exactly what you need in a split second. Like, think of Google,
Right.
but on a scale that's like a million times bigger.
That would change everything.
It would.
Research, data analysis, any field that relies on sifting through tons of information.
Absolutely.
Wow. Now, it's pretty clear that Microsoft is really into quantum computing.
Yeah, they're all in.
The source mentions their Azure Quantum platform.
Yeah, that's their big thing.
What's that all about?
Azure Quantum is basically Microsoft's cloud-based platform for all things quantum. It gives developers, researchers, businesses, whoever, access to a whole bunch of quantum computing resources.
What kind of resources?
Different types of hardware, software, tools, you name it.
Wow.
So they're making it easier for people to get involved in this, cutting-edge technology without having to build their own expensive stuff.
It sounds like Microsoft is taking a page from the early days of the internet,
Yeah.
providing access to a technology that was once only available to a select few.
Democratizing it.
And that's awesome.
It is.
The more people we have working on this, the faster we'll be able to unlock its true potential.
Right. The more brains, the better.
It feels like we're on the verge of something truly incredible here.
It does, doesn't it? Like a whole new era.
But as with any new tech, I imagine there are going to be some challenges along with all those opportunities.
Oh, absolutely.
So as we wrap up, let's maybe shift gears a bit.
Okay.
What are some hurdles that still need to be cleared before quantum computing really hits the mainstream?
Well, scalability is a big one, for sure.
Scalability.
Yeah, like building quantum computers with tons of qubits and keeping them stable, that's tough.
Right, those super low temperatures, the specialized housing unit.
Exactly. Imagine trying to scale that up to thousands or millions of qubits. That's a huge engineering challenge.
It sounds like we're still in the early days of this quantum adventure.
We are, it's true.
Kind of like the early days of computers, those giant room-sized machines.
Exactly. But hey, we've come a long way since then.
That's true.
And progress in quantum computing is happening so fast.
Yeah, it really does seem to be accelerating.
It is. Companies like Microsoft, IBM, Google, they're pouring resources into this research.
I mean, they're betting big on this.
They are, and we're seeing breakthroughs all the time.
That's encouraging. So what's your take on the timeline?
Timeline.
Will we all have quantum computers on our desks anytime soon?
On our desks, probably not.
Okay.
But I think we'll definitely see more and more access to quantum computing power through the cloud.
Oh, interesting.
Platforms like Azure Quantum, they're making it way easier for people to tap into this power without having to build their own hardware.
That makes sense. It's like the way technology typically evolves, right?
It
Starts out in these specialized labs and eventually becomes accessible to everyone.
exactly like the internet.
Exactly.
And as this tech matures, gets more affordable, I think we'll see a whole explosion of applications, things we can't even imagine right now. It's a really exciting time to be watching this field.
Exciting is an understatement. We've gone from, like, the basic building blocks of the universe to unbreakable codes, self-driving cars, maybe even cures for diseases we thought were impossible to cure.
It's mind-blowing, isn't it?
It really is. Quantum computing seems like a true game changer. The potential to reshape the world is huge.
It is. And you know the craziest part?
What's that?
We're really just at the very beginning.
Just getting started.
The real potential of quantum computing, it's still unfolding. We haven't even seen it all yet.
So to wrap things up, what's one key takeaway you'd like to leave our listeners with?
I'd say the most important thing to remember is that quantum computing isn't just about faster computers.
Okay.
It's about a completely new way of thinking about problems.
A new approach.
Yeah, a new approach. One that uses the strangeness and the power of quantum mechanics.
Oh, yeah.
And while there are definitely challenges ahead, the possibilities are truly endless.
Well said. And for those of you who are eager to learn more, definitely check out Microsoft's resources. They've got some great stuff on quantum computing,
They do.
including their Azure Quantum platform and lots of learning materials.
Yeah, there's so much out there to explore.
So go out there, explore, and discover the quantum world.
The future is quantum.
Thanks for joining us on this incredible journey. Until next time, stay curious.